This is Mr. Dobrovich, the other AP Stats teacher. Very often you want to compare two or more distributions in science or in business applications. So today we thought we'd give you a little practice with that. Before we do, let's contrast histograms and box plots because they're both super important, but they're good at different things. So take a look at this graphic and look at what information comes out clearly in the histogram versus box plot, and similarly for the diagram over here. And come up with your own answers. What's a histogram better at and less good at? What's a box plot better at and less good at? So go ahead and pause the video. Come up with your own answers. Come back in just a second. Okay, fair warning. Here we go. So what's great about distributions, what's great about histogram views of distributions is they really show you clearly the overall shape of the distribution. What they're not so good at is giving you specific values about the center and spread that would let you easily compare to other distributions. So for example, here we have two different histograms representing different data sets. They both produce the exact same box plot. So in the box plot, you can't actually see the overall shape of the distribution. The box plot has hidden from you the fact that this is unimodal and this is bimodal. If there were big gaps in the data, you'd never see it in a box plot. So that's what histograms are good for. Big picture overall shape of the distribution. And then conversely, what box plots are good for is the thing that histograms are not, which is giving you specific values for kind of overall center and spread features of your data set that would make it easy to compare to other distributions. So let's write down a little bit more detail in here. So for some details about what do I mean when I say the overall shape of the distribution, if it's skew left or right, if it's symmetric, if there are gaps in the data, if it's unimodal or bimodal or uniform or multimodal, and if there are any apparent outliers. And I put a question mark there just because it may not actually be useful to see if there are apparent outliers. Maybe what you really care about is here in the box plot if you can actually see explicitly marked outliers. So now let's fill in box plot. Like I said, it's strong where histograms are weak. So in the box plot, we've got explicitly marked set measures of center and spread. And so the center that a box plot marks is the median. And the spread, you can easily see both the range and the interquartile range, the IQR. I'm sorry these boxes are so tiny. You can also see the skew, whether or not your data is skew or symmetric. In the histogram, the skew is the... Ooh, let me ask you, quick quiz. Is this skew left or skew right? If you said skew right, you are correct because the skew is in the direction of the tail that you see. In the box plot, you can also see if data is symmetric or not. Remember that each of these segments is a quartile of the data, so 25% of the data. So if you have 25% of the data in that width and 25% of the data in something with a greater width, you know that this data must be more spread out, therefore skew in that direction. So whenever you see longer boxes or whiskers on one side than the other side, that means the data is skewed in that direction. And then another nice thing about box plot is it explicitly marks the outliers. Like you calculate where the fence is as Q3 plus 1.5, the interquartile range, and then any data outside that is an outlier. And then as I said over here, like the box plot totally hides the overall shape of the distribution, doesn't show that. So in summary, box plots are perfect for comparing different distributions as long as you're sure that you know the underlying shape of the distribution. If you don't know the underlying shape, or if that's important, you want to look at histograms also. Actually comparing distributions, here we've got the track lengths in minutes of the top 100 Spotify songs in two different genres, metal and hip hop. So again, pause the video, look at these box plots and tell yourself a story. What does this tell you about the variability of track lengths in these two different genres? So if you remember CSCSO, to compare distributions or to describe a distribution, you would want to describe the context, the measure of center, the measure of spread, the shape, whether or not there are outliers. So when you're comparing distributions, you want to hit a lot of those same things. But the goal is not to robotically just have one sentence saying this is the center and one sentence saying this is the spread. the goal of all of these descriptions and comparisons is to give your reader some understanding of what this data is telling you. So I'm going to show you some sentences here that fulfill the requirements very minimally, but aren't very good sentences, and then we'll fix them. So if you were going to notice things about the center or about the spread or about other notable similarities or differences, here's some sentences you might write. You might say, metal has a higher median than hip hop. Like, very obviously, here's the median, here's the median. Yes, that's true. This isn't as useful a sentence as it could be, and in the AP test, it wouldn't get you as large a score as another sentence. If I was going to compare ranges, I could say hip hop has a range of 1.4, IQR of 0.8. Metal has a range of 1.4, IQR of 0.6. And then you might also observe that the metal distribution is skew left. You can see because the box plot is longer here on the left and the whisker is longer. While hip hop is symmetric. Okay, so I'd say the main thing that's missing here is context. You should never say median or range or IQR without indicating the units that these are in, which for us are minutes. We're talking about track lengths. We're not talking about like beats per minute, track speeds, for example. So let's adjust some of these sentences. So you might say that metal tracks have a higher median track length than hip hop. And here we've got that keyword track length in there saying, like, what is the median describing? I think it's probably worth noting that it's actually significantly higher. You see that the median metal track length is as long as the longest hip hop song. So let's write a sentence about that. So here I've just said the median metal track is as long as the longest hip hop track. So for measures of spread, we've got the same range for each genre. The IQRs are slightly different. Is the difference between 0.6 and 0.8 significant? So you could calculate what that is. Remember, these are in minutes. So a difference of 0.2 minutes is the same as 12 seconds. I don't feel like 12 seconds is very significant for tracks that are like 3.6 to 4.4 minutes in length. 12 seconds is about 5% of a 4-minute song. So I think we're safe to say that the spread of these two genres is comparable. So I could say both genres have a comparable spread, and then I'm actually going to name the spread. I'll say range of 1.4 minutes, and then IQR of 0.8 minutes for hip-hop and 0.6 minutes for metal. Hip-hop tracks are symmetrically distributed around the median, while metal tracks are slightly skewed left. So I'm clearly comparing measures of spread and shape in both distributions, and I'm naming what they are, and I'm including units of minutes. So there's a lot of other things you could have noticed. If you didn't write the sentence up here about the metal median track length being the same as the longest hip-hop song, you could have written that down here. Another notable thing is the middle 50% of metal tracks are all longer than the middle 50% of hip-hop tracks. So there's no overlap there at all, which I think is notable. So there you can see my sentence. Middle 50% of metal tracks are longer than the middle 50% of metal tracks. Oh, wow, I'm really bad at this. Hold on. You can't see, but it's early in the morning. It's like 6 a.m. Side. I've hidden the worksheet for a second because I wanted to show you, like, this is how data often comes to you. You just have like a list of numbers. So let's imagine that we have a startup. We're trying to sell an app. The place that we're selling it will report to us how many downloads or how many click-throughs or whatever you want to measure, like whatever our sales are per day. So you could imagine like this is January 1st and this is January 2nd and this is January 3rd and so on. So you just have like a list of numbers. So if you want to understand what's going on with your sales, like how can you visualize all of these numbers? Like one thing you might try would be, let's make a histogram. So I did that. You can see that the sales are kind of symmetrically distributed around a median of apparently like 70-ish sales per day. So that's like a little bit interesting, and we can see like what day did I sell the fewest and what day did I sell the most. But this might not capture trends over time. So instead, you could make like a line chart where the x-axis would be each subsequent day, and the y-axis would be sales for that day, and you just see it, the sales bouncing around. And I made this data up. This is fake data, so that's why you don't see any like annual trends in the sales. But now let's jump back to the worksheet. Like I say in the worksheet, it's very tempting to to plot your data like this, but this kind of display is maybe not as informative as it could be. So instead of just plotting points for the daily sales for every single day in sequential order, you could group the sales by months. And then you could look at box plots for the distribution of sales per day for each month separately. And that's what we have here. So you see these are all the January sales, February sales, March sales, April sales. So go ahead, look through this, see if you can fill out. Oh, did I not fill out this? Oh dear. So I will print out a new copy where this is filled out, and you go ahead and see what you can write here. Ta-da! Okay. So which month had the highest average downloads? So remember, average downloads, average is like a measure of center. And here the box plots mark the medians. So we can find the one with the highest median, and it looks like it is August. And which month had the day with the most downloads in it? That would be like the maximum. And whether or not you should include outliers sort of depends on your purposes in asking the question. My purpose is just to have you think about this. So it doesn't matter, but the answer is November either way. So we can write November. Okay, for which month did more than 75% of the days get more downloads than January's best day? So you probably got to think about that a little bit. So let's see, January's best day. Let's find that. So here's January. The best day is here. So it seems like January's best day is like maybe 85-ish views. Or did I say views? I should say downloads. So the question is, which months for which months do more than 75% of the days have more than 85 downloads? So remember, 75% of the data is captured by everything to the right of the left edge of the box. So it's sort of everything that's not that left whisker. So this is very approximate, but here's a vertical line. So it seems like June, July, August, September, October. All of those are months where 75% of the data is to the right of that line. So you can just write June through October. Okay, so which months had the most obvious right skew? And in this context, what might cause a right skew? It's always nice to try and imagine like what might explain the patterns that you're seeing in the data. So this one's a little trickier. So again, just visual judgments. It looks like November has a pretty significant right skew. July, maybe a little bit. May looks like it's got a pretty good one. So actually, I'm just going to write November. But then the question is, what might cause a right skew? Okay, so here's one thing a student might write. A right skew may be caused by more days having sales above the median than below. Two problems with this. The first problem is this is trying to say, what does it mean to be right skew, not what would cause that to happen in this context. And the second problem is this is actually completely wrong. Remember, a median value by definition means that exactly half the data is larger and half the data is smaller. So it's not the case that more than half the sales will be above the median. What it means is that the half of sales that are above the median are more spread out. So that would be, all right, so let's change it again. Okay, so now I've fixed it so at least it gives the right definition of skew. So a right skew might be caused by more variability in the sales for the best 50% of days in the month. So that's saying take the 50% of days larger than the median, and if there's more variability, that must mean that that side of the data is more spread out, and that's what causes the skew. But the problem is I'm still not really saying what might explain the right skew. I just said, what does it mean to be right skewed? Not why might that happen in November, or why might that happen for sales of our product. So here would be one example of a kind of an answer. An event such as getting mentioned on a popular podcast might have caused a brief increase in downloads for a couple of days, causing a right skew. And another thing I'm noticing here is in November, we've got the right skew. It's actually got a much lower median sales number or downloads number than the previous months. So it could be something like we were selling pretty well over the summer up through October. Then in November, we see a dip. And so halfway through November, we secure a spot or an interview or something somewhere publicly seen. And so then maybe in the second half of November, we saw some increased downloads. And so that's why overall we've got a low median. But for the days where we did well, we did much better than the median, causing that right skew. So thinking down to the level of what might actually explain what we're seeing is an important skill and kind of tricky. We just wanted to give you a little bit of practice with that. All right, to round it out, finish this one for homework, and we'll go over the solutions first thing in class. We've got a university that wants to conduct a study of a new medicine that is designed to help with high cholesterol. We've got the ages for 2 possible groups of patients that could be used in the study. So we've got ages. So practice making parallel box plots. It is something you'll have to do on the AP exam, be able to produce visualizations by hand. And then compare the 2 groups, or compare the 2 distributions and answer this question with this tiny, tiny space below. Good luck. See you next time.